Good morning everyone. Welcome to the course Machine Learning. I am S.Spandana, Assistant Professor, Department of CSIT, MLR Institute of Technology, Hyderabad. In the previous session, I had discussed about the topic unsupervised learning and what are the types of unsupervised learning with some real-time examples, and also I had discussed what are the advantages and disadvantages of unsupervised learning. And now today, the overview of today's session, I am going to discuss about what is reinforcement learning and what are the types of reinforcement learning and what are the positive reinforcement learning and negative reinforcement learning, and what are the difference between positive reinforcement and negative reinforcement, and what are the real-time applications of reinforcement learning, and what are the advantages and disadvantages of reinforcement machine learning, and what are the algorithms that comes under reinforcement learning, and lastly I am going to discuss about the summary of the overall session. Coming to what do you mean by reinforcement learning? The reinforcement learning is a type of machine learning where a computer program is to learn, make decisions by trying different actions and receiving feedback in the form of rewards and penalties. That means the reinforcement learning is going to work in the form of rewards and penalties. That means for each correct action, you are going to get a reward for it, and for each wrong action, you are going to get a penalty for that. So that's how the reinforcement machine learning is going to work in the form of rewards and penalties. For each correct action, it is going to get a reward or a positive feedback, and for each incorrect action, it is going to get negative feedback or penalty for that. That's how it is going to work in the form of rewards and penalties. Let me explain you with one example how the reinforcement machine learning is going to be worked. Actually, the reinforcement machine learning is the interaction between the environment and the agent. That means it is performing the action in two ways. It is the interaction between the environment and agent. The agent is going to perform in two actions. That is exploration and exploitation. The agent is going to perform actions in the form of two ways, that is exploration and exploitation. Here, when the learning agent is going to receive like a trial and error basis, it is known as exploration. When the agent is going to learn or acquire knowledge from the environment, it is known as exploitation. That's how the learning agent is going to be worked. So here I can tell you with an example. Here we are having an input raw data. Here you can see in the image agent. Here the agent needs to identify whether it is an apple or not. Here what we are going to do? We are going to train the machine with the help of reinforcement learning algorithms. Once the model is trained, after training, the model is going to detect the output, predict the output. For example, I have given an input apple. After the training, I have passed the input apple. So once the model is trained, it is going to predict the output that it is an apple. So that's how the reinforcement machine learning is going to be worked between the environment and agent. Let me explain you with one more example. Here you can see the agent who need to judge from the environment which of them is a duck. So here that is a task given to the agent. So here by using some optimal fallacy, the agent is going to detect that bunny as a duck. The machine is going to detect bunny as a duck. Actually, it is going to get minus 50 points for it because that is not a duck. So, for that it is going to get penalty for it, because it is a wrong answer. Whenever it is going to the incorrect action, it is going to select the incorrect option, then it is going to get penalty, that is minus 50 points for selecting the wrong answer, like selecting bunny as a duck. Next, here by obtaining some policy, it is going to, the agent is going to update its policy, and using that optimal policy it is going to continue, and it is going to know that, recognize or realize that this is not a duck. So, in that way the agent is going to identify that it is not a duck. Let me explain you with one more example. One of the most popular use cases of reinforcement learning. For example, here as you can see in the image, Pablo has trained his dog. Pablo trained his dog in 4 stages using reinforcement learning method. Let me explain each step. In the first step, you can see that Pablo has trained with reinforcement learning here. In the first step, you can see that the Pablo has given food to the dog. Then what the dog is doing? The dog started salivating. Then after, in the second stage, the Pablo has rang the bell. So here, the dog, there is no salivation from the dog when the bell has rung. That is the second step. Then coming to the third stage, so when the Pablo has rang the bell and also given food, then what the dog is doing? The dog started salivating, bell along with the food. In the fourth stage, what Pablo did? The Pablo just rang the bell. So, what the dog is doing? The dog started salivating. That means the dog has trained with the help of reinforcement machine learning algorithms, and based on that the dog has been trained. So based on that the dog thought that when the bell has rang, the Pablo will get the food for it. So that's how the reinforcement machine learning training has been done to the dog. Then coming to types of reinforcement learning. Reinforcement learning can be further divided into 2 types, that is positive reinforcement and negative reinforcement. Let me discuss each in detail. Coming to positive reinforcement learning. The positive reinforcement learning means adding something to increase the tendency that expected behavior would occur again. That means it impacts positively on the behavior of the agent. Here the agent is going to get the actions. For each correct action, he is going to get a reward for it. That is nothing but positive reinforcement learning. The positive reinforcement learning is a recurrence behavior due to the positive rewards, as you can see. For each correct action, it is going to get the reward for it. That is nothing but positive reinforcement learning. Rewards is going to increase the strength and frequency of a specific behavior. This encourages to execute similar actions that is going to yield maximum rewards. So, how many rewards it is going to get, that much highest score it is going to perform. It is nothing but in the form of rewards. That is known as positive reinforcement learning, in the form of rewards for a particular correct action. Next, coming to the second one, the negative reinforcement learning. The negative reinforcement learning is the opposite to the positive reinforcement, that as it increases the tendency that the specific behavior will occur again by avoiding the negative condition, that is a negative feedback, that is nothing but penalty for it. Penalty for each incorrect action is nothing but negative reinforcement learning. It can be more effective than positive reinforcement depending on situation and behavior, but it provides reinforcement only to meet minimum behavior. That means negative feedbacks. In negative reinforcement learning, negative rewards are used as deterrent to weaken the behavior and also to avoid it. That means here in negative reinforcement learning, rewards decreases strength and frequency of a specific behavior. That means here we are going to get the negative feedbacks. Negative feedback, or we can also call it as penalty for each incorrect option. That means the negative reinforcement learning is worked in the form of penalties or the negative feedback. This is known as negative reinforcement learning. Let me explain you with one example. For example, Maze Runner is basically a maze game with obstacles defined. Here, you want the hero to reach the other end as shown in the image on its own way. That how can it be performed? It can be performed with reinforcement learning. The reinforcement learning will do that. How? For example, here, red star. The star indicates this is a beginning point and this is an end point. Here we have two stars. We have to reach from one source to destination, that is begin to end. How can it can be reached? For example, here you are having a block dots which is known as blocks, where the star should not pass over that blocks. If the star is going to pass through that, then it is going to get penalty for it. Whenever actually the goal of this is to reach from source to destination without crossing over this blocks. Then what it should perform? It should select the possible paths. It should select the possible paths to reach from source to destination without crossing over the black dots, that is blocks. So it is going to select a particular path. Whenever it is going to select a correct path, then it is going to get reward for it. For example, whenever it is going to select this path, then it is going to get penalty for it. So based on that, it is going to learn from that and it is going to improve better. So it is going to select the other path, then other path, then it reaches the destination by getting the highest rewards. So whenever it is going to select the wrong path, it is going to get the penalty for it. So that's how it is going to reach in the form of trial and error basis from source to destination. That is about the Maze Runner game using reinforcement learning. Let me explain you with one more example. As you can see in the image, we have an agent and with rewards with many hurdles in between. The agent is supposed to find the best possible path to reach the reward. As you can see in the image, robot is an agent. And next, fire hurdles is a penalty. That means a wrong action. And the diamond is to reward. The goal of the robot or agent is to reach the destination, that is diamond. So he should select a particular path to reach from source to destination, that is diamond. So he should not cross over the fire hurdles. Then what happening? It is going to get penalty for it. He should not go to the back step. Whenever he entered to the forward step, he should not enter to the back step. That is one condition. And whenever he entered to this step, he need to go forward. He need to go forward step and then he need to select the best possible path. Best possible path to reach the destination, that is diamond. Whenever he is going to select the correct path, he is going to get the reward for it. Whenever he is going to select the wrong path, then he is going to get penalty for that. So based on that, he is going to select the correct path with a like trial and error basis. Then he is to select this path. Then finally, he reached the destination by selecting the best possible path without crossing the fire hurdles. Then he reaches the destination and the overall rewards will be counted, and based on that getting highest scores and highest rewards, and finally reaching the destination diamond in the form of trial and error basis. That is nothing but reinforcement learning. Coming to one more example, as you can see in the image, the agent need to predict that which of them is water or fire. Here, he need to touch the water. So, he need to observe from the environment which of them is water. So, he selects some option using some policy, and based on that, he selected the fire. So, for that, it is a wrong action. It is an incorrect action. For that, he is getting minus 50 points as a penalty for that. So, next what? By using some optimal policy, he is going to learn that it is a bad and it is an incorrect action. So, next time, he is going to avoid that because it hurts a lot because of fear. So, that's how the reinforcement learning is going to be trained using the policy like getting rewards and penalties for the wrong actions. And finally, the difference between the positive and negative reinforcement learning. Coming to the positive reinforcement learning, the purpose of it is encourages by giving rewards. That means for each correct action, it is going to get rewards for it. Negative reinforcement learning, it encourages by removing discomfort. That means whenever he is going to select the wrong option, he is going to get a penalty for that. Example, giving a treat for a job well done. That means when the task is performed well, we are going to give rewards for it. And negative reinforcement learning, stopping an annoying sound by acting. So, when there is a disturbance like getting sound and all, it is going to get penalty for that. So, that is nothing but negative reinforcement learning. Action effort. It promotes seeking rewards. Rewards will be counted based on selecting the correct options. And coming to negative reinforcement learning, it promotes avoiding unpleasantness. Next, coming to focus. Emphasize positive experiences. That means positive actions, positive rewards. And here, negative situations, that means negative feedbacks, or also we can call it as penalties. And increases behavior for rewards. Increases behavior to avoid discomfort. That means penalty. Reward or positive outcome. Here, removal of stimulus. That means penalty. So, that's how the main difference between positive and negative reinforcement learning is nothing but for each correct action, it is going to get rewards, and for each wrong actions, it is going to get penalty. For example, you can see in the image, we are having an agent. Here, the agent is this is a source, this is a destination that he need to reach tree. He need to select a possible path. So, like left direction, right direction, up direction, down direction. He need to select the correct path. So, whenever he is choosing this path, it is correct. So, whenever it is choosing here, it is correct. Whenever he goes this side, it is a wrong step because it gets hurt there and he is going to get penalty for that. Then comes back to right position and selects here and reach the destination. So, that's how it is going to select the best possible path to reach the destination like trial and error basis. Whenever it is going to select the wrong path, it is going to get penalty for that. So, that's how it is going to be trained. So, selecting the best path and finally reaches the tree. That's how the reinforcement learning is going to be worked in the form of rewards and penalties. Let me tell you some real-time applications of reinforcement learning. It is going to be work in game playing, autonomous driving, robotics control and healthcare. Let me explain each in detail. Coming to game playing. Game playing in reinforcement learning refers to the use of machine learning techniques to teach a computer program that is known as agent how to play and excel in video games or some games. Many of the people are going to play games on the systems, so that games are going to be developed with reinforcement learning only. It is going to make decisions, take actions in the game environment to achieve the maximized rewards or to get the highest scores. Overall, game playing in reinforcement learning is about training a computer program at playing games by learning from its own experiences, like trial and error basis, like rewards and penalties, rewards for the correct actions, penalties for wrong actions. That is nothing but rewards and penalties. The process can be extended to more complex games and the real world applications to entertain the people, such as robotics, decision making and optimization problems. As you can see, many of them are playing games. Example, Fruit Ninja game, Flappy Bird game. It is in the mobile nowadays. Every game you can play, and in the nowadays smartwatch also providing this game, chess game, racing game. Likewise, the lot of gaming applications are developed with the help of reinforcement machine learning. Let me explain you with one example. Example is Fruit Ninja game. Here, the goal of this game is to slice fruits. The goal of this game is to slice as many fruits as you want. This is nothing but Fruit Ninja game. Here, the agent is to slice as many fruits as which is going to be thrown on the gameplay screen. The fruits are thrown in the air. So, based on that, the agent need to slice that fruits. How many fruits he is going to slice, that many rewards he is going to get. And also, he should avoid these bombs. This is known as bombs. The agent only needs to slice as many fruits as he like. So, as many fruits, then he is going to get rewards for that. And also he should avoid bombs. If he is not going to avoid bombs, he is going to get penalty for it. So, that's how the agent is going to be trained by avoiding the bombs and also slicing as many fruits as he want. By avoiding the bombs, he is going to be, the machine is going to make perfect, better based on this reinforcement machine learning. Next real-time application is autonomous driving. Autonomous driving in reinforcement learning involves training self-driving vehicles by taking decisions by learning from their interactions with the environment. So, nowadays autonomous driving has been become popular. It is going to use reinforcement learning. It is going to occur. It has a safety handling complex and unpredictable traffic scenarios and addressing and ethical moral considerations. And reinforcement learning offers a way to create adaptable self-driving systems that can learn from experience and navigate real-world environments. That means it is going to learn from its own experience, like trial and error basis, based on that reinforcement learning. Self-driving cars are also using reinforcement learning to make real-time decisions while navigating through complex traffic scenarios and also avoiding obstacles, and it is going to provide passenger safety with the help of this reinforcement learning. Let me explain you with one example. Tesla's self-driving car is going to be developed with the reinforcement machine learning technology to provide the passengers easiest way and smooth way to travel the patients safely. That means here autonomous cars are going to create and maintain a map around their surroundings based on the sensors developed situated in the car, and also it can follow some traffic rules. That means the videos cameras are going to detect the traffic lights, and it is going to read road signs, and also it is going to look for the pedestrians who are walking on the road. So, based on that, it is going to be trained with the help of reinforcement machine learning, and it is going to protect the pedestrians and making the travel safe to reach a particular destination with the help of the sensors situated in the vehicle, and also giving the training to that with the help of reinforcement machine learning. It makes the passengers to travel safely to reach the destination. That is about the self-driving car developed with reinforcement machine learning. Coming to the other real-time applications of robotics control. The robotics control in reinforcement learning involves training robots to perform tasks and make decisions using a learning approach that is through trial and error basis. It is going to work on the changing environments. It is going to learn new tasks and also more capable over time to learn, improve through practice. Let me explain you with one example. That is drone flight control. As you can see in the image, we are having the drone flight control. Actually, the main goal of this drone flight control is designed to fly and navigate through the different environments. That means the main goal of the drone flight control is to fly at a correct height and also maintain stability. And also fly at a correct height. Based on that, it is going to perform the task for us, like what it is doing here. It is going to track the agricultural land with cameras, that it is going to capture the pictures, and also the drone flight control is also going to deliver the medical kit, and also it is going to do food delivery safely and securely. So that's how the drone's flight control is developed with the help of reinforcement learning to make the task easily performed without humans. So that's how the drone flight control is developed. Next, coming to healthcare. Healthcare in reinforcement learning involves the application of reinforcement learning techniques to improve the medical treatments, decision making and resource allocation with the healthcare sector. So it is also be useful in healthcare sector. So like medical decision making and treatment strategies, resource management and more effective and personalized patient care is developed with the help of reinforcement learning. Let me explain you with one example. That is personalized diabetes treatment. Nowadays everybody are facing with the diabetes problem. So how can we reduce this one? For example, here imagine a patient with diabetes need to maintain his blood sugar levels with the help of insulin therapy. So there is a machine developed that how much insulin is to be given. For example, the main goal of this personalized diabetes treatment is to check the blood sugar levels. Based on that, whenever the machine is going to recommend insulin for each person to check the blood sugar levels. So whenever the blood sugar is high, we should offer the insulin more. Whenever the blood sugar is low, it should offer the insulin less. That's how the machine, the personalized diabetes treatment machine is going to be trained on the insulin. It gets rewards whenever the stable blood sugar levels are there correctly, and it is going to get penalty whenever it is high blood sugar or low blood sugar. So for that he is going to get a penalty. Based on that, it is going to detect how much insulin is required for that patient based on checking the blood sugar levels of a particular patient. So with the help of this, the patient is going to stay healthy by maintaining the blood sugar levels maximum or stable level with the help of this machine. So that means it stays healthy. The patient is going to be stay healthy with the help of this machine that was developed by reinforcement machine learning. Next, coming to what are the advantages and disadvantages of reinforcement learning. Advantages. The first one is personalized decision making, that is going to make decisions on its own. Next, coming to the disadvantages, data requirements. Sometimes the data may not be available in the reinforcement learning. And next advantage is adapts to the changing environment. It is going to perform based on the situations occurred, it is going to work in any type of situations or any type of challenges. Coming to the disadvantages, computational complexity is nothing but it is going to get some complexity based on the data provided to the system. Next, coming to advantage, handles complexity. This reinforcement learning is also going to handle some complex tasks which cannot be solved by supervised or unsupervised. It is going to be solved here. Exploration challenges. That means it cannot be changed, it cannot be performed well based on some challenges or situations occurred. It cannot be having some power to explore the challenges. And next advantage is learns from experience. That means it is going to learn from experience, that is trial and error basis. For each correct action, it is going to get reward. For each wrong action, it is going to get penalty. So that's how one of the advantage. And next disadvantage is delayed rewards. That means it is going to get sometimes for a particular actions, it is going to get rewards very slowly. That means learning time is slower here. That is one of the disadvantage. And the final advantage is autonomous learning. That means the autonomous learning is become easily without humans. The machines are going to perform the things easily with the help of some data provided to that. And the risk of overfitting is one of the disadvantages of reinforcement learning. The system might be at risk whenever the too much data is provided. It is not going to be handled for a particular too much amount of data. That is one of the disadvantages of reinforcement learning. And what are the list of algorithms that comes under reinforcement learning? That is Q-learning and deep Q network, DQN. These algorithms are going to be discussed in the later coming sessions. That's all about today's session. The summary of today's session is we have discussed that what is reinforcement learning, that is going to be work in the form of rewards and penalties. That means for each correct action we are going to give rewards, and for each wrong action we are going to give penalty for that. And types of reinforcement learning, that is positive reinforcement and negative reinforcement. So for positive rewards, for negative penalty. That's how the two types. And difference between reinforcement and positive reinforcement and negative reinforcement, that is positive means rewards, negative means penalty. And then some real-time applications of reinforcement learning, that is self-driving cars, and also the diabetes treatment and drone flight control and the robotics. So many real-time examples I have explained, and what are the advantages and disadvantages of reinforcement machine learning, and what are the algorithms that comes under reinforcement learning. So that's all about today's session. In the next coming session, I am going to discuss about some applications of machine learning. Keep watching. Please like, comment and subscribe. Thank you.